So we are back again with another video. In this video, I will briefly summarize to you the following topics just to give you an overview. So without further ado, let's get started. Let's start with the manufacturing process. In this part, we can see a chain of production line from a fabless company. It goes to the foundries, which take care of the manufacturing part, and some outsource are being processed in OSATs for packaging if they are overloaded, and then back to the fabless companies. But nowadays, some foundries take care of both manufacturing and the packaging. And there are also companies that are capable of doing things themselves, and they are called the IDMs or the integrated device manufacturers. Next, we can see how the single die packaging evolved from having a single chip into those that have more dies integrated into it, thus having more functionality and is more optimized. SoC, MCM, SIP, and SOPs are the best examples. Technology also evolved as we move forward to advancement. Here are examples of packaging that has transformed. First, TIP, SIP, and CDIP, which are from pin-through-hole technology. Today, surface mount technology is widely used like QFP, pin grid array, and ball grid array, which is common on our microcontrollers. Sometimes we can see a combination of these two packaging. Also, we have silicon interposers. This serves as a link from the inputs and outputs of the package, and it can be implemented on either horizontal or vertical manner. It is more optimized in heat-related aspects, and it eliminates the use of wire bonding. These are the most notable parts of the silicon interposers: the TSV, RDL, and UPM. Utilizing the advantages brought by the interposers, various companies used this as a stepping stone into having a more advanced packaging process from 2D to 2.5D. Further development of 2.5D, we now have 3D, which mounts two or more dies in on top of each other. Both of them are under subcategory of SIPs and have their own advantages. Here, bonding techniques of interconnections are being discussed. The following are the most common ones: wire bond, which uses wires to connect the die and the packaging; the flip chip, which utilizes solder bumps to connect the semiconductor device to the board; and the interposers, that is between the die and the substrate, which makes it more efficient and have optimized performance, but it also comes to a much higher price. Some demands in the industry, like reducing the size of the packaging, increasing the performance while having a higher yield, finding an easier way to test the die, and something that comes with a much lower price, are the reason that lead to the advancement in terms of packaging. Here we have a wafer level packaging. It is a conventional way of packaging the die while it is still in the wafer. Although some of the wafers will be discarded since it is not whole, it will then be prepared for the dicing process. On the other hand, we have panel level packaging. Despite having the same concept, it only varies in the shape at the fan out, and it is the new technology used in the industry. And here are the notable difference between the wafer and the panel level packaging. The wafer level packaging had a standardized process, while the panel level packaging lacks standardization since it uses a new technology. With the wafer level packaging having both fan-in and fan-out, the panel level packaging uses only the fan-out option. When it comes to price, You save when you choose panel level packaging, since it comes with a much cheaper price compared to its wafer level counterpart. Both of them had production issues, but on the panel level packaging, it is already augmented. That ends our discussion. Bye!